So we're Zeroth Index, and we're here to talk about our proposal to create virtual power plants using DER aggregation. I'm Sam, and this is the rest of our team. So right up front, there's a few terms we'll be using a lot throughout our pitch. So DER will refer to small self-contained energy systems like rooftop solar, storage batteries, and electric vehicle batteries. Meanwhile, regional grid operators refers to the bodies overseeing and managing regional power. So that would be like Avangrid. And foundational to our challenge is a recent law from New York called Order 2222. Essentially, it allows groups of DER owners in New York to pool their resources and sell power in a wholesale market, which is pretty huge. However, currently there are no tools in place to assist in resource aggregation or management. So our goal was to leverage this new law in a way that creates efficiencies and advantages for all parties involved, and our solution comes in the form of community virtual power plants. This idea that we can aggregate existing privately owned DERs as relatively inexpensive ways to increase grid size and efficiency. As an example, this basic flowchart depicts a local power grid in our current system, starting with power coming in from regional power plants and ending with it being transferred to your home. As you can see, the homeowners' DERs are completely uncoupled from the main power grid, meaning they exist only as power supplements, and as a result will be very underutilized. We believe that resource aggregation can address these inefficiencies. In this power grid with aggregated DER management, we can see that now every DER is connected directly to the power grid through the house's smart meter. This allows the grid operator to utilize them as if they were an existing part of the regional grid infrastructure.
When identifying an optimal location to implement these virtual power plants, we have to consider key factors in order to maximize the benefit we can achieve from aggregating rooftop solar and batteries. These factors include high energy prices, pre-existing solar capacity, grid instability, and potential for future investment. We have identified two locations in upstate New York that would benefit the most from DER aggregation: Albany and Ithaca, New York. But these areas both have relatively high average energy prices and currently hold large amounts of rooftop solar. Aggregating DERs in these areas can provide benefits to both Iberdrola and consumers. With lower costs, grid stability, reduced carbon emissions, DER aggregation is a win-win. Here's just one example of how DERs can be leveraged to benefit the entire grid. As you can see, the integration of solar and batteries reduces peak demand by as much as 60%. If these technologies are aggregated over thousands of homes, Avangrid will be able to save hundreds of thousands from a reduced need for peaking power generation.
In the light of the limited infrastructure of small-scale energy storage, electric vehicle stock forecasts and predictions of vehicle-to-grid contributions make for a strong case for utilizing electric vehicles as a potential DER. In the past and present, electrical vehicle infrastructure has overshadowed small-scale energy storage in terms of annual capacity, as seen on the graph on this slide. This trend continues into the future, with most notably solar power's contributions as a DER are anticipated to be overtaken by EV infrastructure, making electric vehicles an even more compelling resource to take advantage of. Furthermore, electric vehicles are rapidly gaining in popularity throughout the United States. 18 million electric vehicles are projected to be on the road by 2030 alone. Therefore, by 2030, the U.S.'s projected vehicle-to-grid contributions will total nearly 90 gigawatts of energy. In New York, the NYSEG's and RG&E's goal for 30,000 megawatts of energy storage will be achieved using a mere 5% of the projected electrical vehicle stock within the state.
As an action plan, we recommend that Avangrid invest in the installation of smart meters in homes, which would physically enable households to create virtual power plants. With that, we advise that they should develop a platform that allows DER owners to aggregate and sell electricity to the grid at a rate determined by Avangrid. And finally, Avangrid should create an algorithmic management system that optimizes for when and where the utility should draw electricity from these virtual power plants into the grid. This unlocks profits for both the utility and the consumer through the energy arbitrage and non-wires alternative savings, as we've discussed previously. With that in mind, this action plan can provide huge benefit for consumer and utility through non-wires alternatives that can defer and, as a case study by the Peak Load Management Alliance indicates, replace the need for hundreds of millions of dollars in annual infrastructure upgrades. We thank you for your time and would like to open the floor to questions.
So a quick question. You mentioned the participation in the wholesale power markets, and then I didn't hear much of a call back to that. Can you talk about the sort of balance between potentially other benefits by participating in this virtual power plant and the benefit of participating in the wholesale market? Are those the same program? Are they different programs? How is the utility managing that?
So we see that as the same program, where essentially the utility would create this program and this platform where you could have different DER owners aggregate together. And by opting into that program, they set up this agreement and pretty much this buyback program of electricity with Avangrid. And that's where first the arbitrage opportunity comes in for Avangrid, of where essentially you're purchasing energy from these DER owners at a rate below the current market rate, and then selling back to non-DER like consumers of electricity. And then on top of that, what that gives you as a part of that is you can create agreements within that platform where there can be certain uptime requirements or whatnot that Avangrid can then use with its management system to help defer maintenance and to help increase grid stability.
Do you have any sense of, thinking about the cost or the benefit to the utility, the value of the utility of those grid services versus using the energy from those DERs to participate in the wholesale market? Is there, I guess, can the utility compete with wholesale market rates to solicit some of that DER capacity from the owners? Or would there be a scenario where the owners could always get a better rate by just selling all of their capacity to the market?
So our proposed solution actually helps avoid that situation, because if you're in a situation where you have like DER owners who have like coagulated together independently, like then absolutely they can totally do that, and like you would have to make that calculation. But if Avangrid comes in and provides the conduit for them to aggregate and to aggregate under certain terms, that's where that becomes like less of a concern, because then Avangrid is able to turn the lever on what exactly are those wholesale prices. And also on top of that, it's able to go and calculate like, hey, what savings do we have? Like in a case study that we looked at, like there was a New York State energy company that was able to go and invest $200 million to prevent like the addition of an additional substation and all this different wire infrastructure, and just being able to do that without that extremely high upfront investment is, I think, a huge benefit, and it compensates for the drawback of having to purchase back energy from owners.
So in that scenario, would Avangrid like offer paying back, $100 million to the DER owners, so that their cost of stabilizing the grid using the DERs was 100 million versus, spending the 200 million to upgrade the system? Or would it just be sort of like, if you want us to aggregate and create any value for you, we're just going to determine how we're going to do that?
It would be like, the thinking behind it would be more of the former, but from the consumer side, it would look like the latter.
Okay. And Hara, sorry, I think you were starting to ask a question.
No, I think there is no time. At the end of your presentation, you refer that the study case, the case of the study, shows that your model works. You can explain one of the case of the studies shortly, very shortly.
Which slide was it?
Cases indicate that this approach. No. At the 19.
The previous. There.
That is there.
Here. Okay.
19.
Slide 19.
Okay. You want to explain one of the cases, maybe?
Case studies.
Yeah. So it was actually one of the cases that I discussed. It was in our source the non-wires alternatives report, and I can pull it up here. The yeah, and so
no, if you can do it shortly, no problem. If you can, if it is so complicated.
I'm sorry.
We're out of time. Thank you.
I think we're out of time. Yeah. Okay.
Yeah.
Okay, no problem. Thank you.
Thanks, guys.
We can post it in the Slack as well. Awesome.
Okay, sure.
Thank you so much.
Thank you.
Bye.